கோமதி அந்த லிங்க் அனுப்பிச்சிருப்பாரு, உடனே ட்ரை பண்ணிட்டு சொல்லு. நீ சொன்னதுக்கப்புறம் நான் சென்ட் பண்ணேன். ஓகே, உடனே ட்ரை பண்ணேன். வாட்ஸ்அப்பில் போட்டிருக்கேன் பாரு, டக்குன்னு பண்ணுங்க. ஓகே ஓகே பாய்.
Hello, Tamalmati. Deepa.
Yes, ma'am. Yes, ma'am.
Can you see the, good morning? Can you see the presentation screen?
Yes, ma'am. But presentation is not available, ma'am.
Yeah, I'll put. Everything is fine, ma'am.
Yes, ma'am.
Sir has come. Yes, Gopi sir. Now
No,
it's okay. Now it's okay.
Yes, ma'am.
Yeah. So get ready. Okay. All the best for you.
சொல்லு கோமதி. சரி. ஆமாம் நான் கவனிக்கல, ஒன்று மெசேஜ் அனுப்பிச்சு விட்டுட்டேன். சரி, ஓகேடா. ஓகே, பாய். பாய் பாய். ஏதாவது ஒரு ப்ராப்ளம்னா உடனே சொல்லிவிடு, சரியா? எனக்கு ஓகேப்பா. ஓகே, பாய். இருக்கான்னு தெரியும்.
Good morning.
Please, Ananda Jyoti, talk your
அவருடைய ஆசையை நிறைவேற்ற ஏனென்றால்
all of you mute yourself.
Hello.
Good morning, Mr. Gopi Parasrama. Welcome.
Hey, good morning. How are you
Good
guys?
morning.
Good.
Yeah, we are waiting. We start sharp at 9 o'clock, okay?
All right.
Thank you. Welcome you all to our international webinar on Artificial Intelligence System, Cloud and Enterprise Architecture. Learning gives creativity. Creativity leads to thinking. Thinking provides knowledge. Knowledge makes you great, said by Dr. APJ Abdul Kalam. To fulfill Dr. Abdul Kalam's words, Department of Computer Science, University of Madras is proud to host the virtual webinar as a platform for young learners to update industry requirements during this COVID pandemic. We, the Department of Computer Science, are happy to welcome you one and all present here for the international level webinar on recent trends in intelligent systems, cloud and enterprise architecture. Happy and good morning to everyone present here. I am indeed very happy to welcome our eminent and honorable resource person, Mr. Gopi Parasurama, Director of Enterprise Architecture, Nike Incorporation, Pemberton, or USA, for this August gathering today for our webinar to deliver a keynote address on From Monolith to Microservices to enrich our knowledge for another 90 minutes. We, the Department of Computer Science, are grateful to our speaker, Mr. Gopi Parasurama, for sparing your precious 90 minutes time and enlighten our active participants with your great input. I am very happy to welcome all our beloved professors, Dr. P. Thangavel, Dr. M. Sornam, Dr. S. Gopinathan, and Dr. V. Lavanya of our department, and other university professors, enthusiastic college professors from various colleges from Tamil Nadu and from various states. I extend my warm welcome to ever energetic research scholars, young student friends from our department and other places eagerly awaiting to update their knowledge. Welcome to one and all present here. I am sure this session would be an eye-opener for beginners and update their domain knowledge for others. With this, I have another inbound duty to introduce our eminent resource person of the day, Mr. Gopi Parasurama, Director of Enterprise Architecture, Nike Incorporation, Pemberton, or USA. He has got a very good, rich experience and he is an accomplished servant leader with 20 plus years of experience of delivering digital transformation programs for Fortune 500 retail, commerce, and omni-channel companies through enterprise technology, strategies and engineering, influential and hands-on leader with in-depth emphasis on building relationship through collaboration with business and technology teams. He has proven track record of delivering highly scalable supply chain solutions on cloud using web services for e-commerce, omnichannel customers. We are happy to have such a honorable and eminent resource person with us today. So he has got an expertise on cloud migration, AWS, microservice architecture, architecture and roadmaps, omni-channel retailing, supply chain management, portfolio management, budget planning, scale, agile and DevOps, and talent development. He has got a very good rich experience of 20 plus years of experience. He is presently working at Director of Enterprise Architecture, Global Supply Chain Technology, Nike Corporation, and he has worked for various capacities in different companies as developer, enterprise architect, director of engineering, director of software engineering in various locations. And he has done a very good contribution for this enterprise computing. Sir, we are happy to welcome you once again and fortunate to have you as a resource person today to share your knowledge to our enthusiastic participations. He is a certified Scrum Master from University of Washington and he has done CBA course on business administration from University of Washington and he has completed his post-graduation in Alagappa University. Thank you very much for your presence, sir. Over to Mr. Gopi Parasurama for the session.
Thank you, Chithra, for the warm welcome. And thank you everyone for the opportunity to come and speak about the monolith to microservice topic. I'm really excited to be here. And this is morning for you, around 9 o'clock, and it's almost about 8:35 p.m. for me in Seattle, Washington. It's almost 12.5 hours behind you. Sorry, it's been a long day for me, so I'll do my best to speak out. With the COVID-19 situation, I think every company, every retailer is trying hard to sell their products through online. And Nike, being a sports, company primarily focusing on shoes and apparels for sportsmen and athletes and people like us, they have been hit hard, and the sales has been really skyrocketing through our online site. So our workload has been so much, and my days are long, and I'm a little tired, to be honest. Just finished my work and grabbed some dinner and back here to speak. So I'll do my best to talk. And the way I'm going to do is I'll share my slides. I'll quickly go through the agenda, and I have a few talking points. Basically, my PowerPoint is just going to have a few bullet points, but I'll talk through it and give you guys more opportunity, more time to ask questions and keep that more interactive. And feel free to stop me and ask questions after every slide if you want. I know Chithra had put together a break in the middle for Q&A and then another Q&A at the end, but I'm more open to how you guys want to ask the question. Okay, keep it more free. I mean, don't hesitate to ask me questions. But I'm trying to keep this session for an hour and 15 minutes, if that's okay with you guys. Okay. Thank you again, and let me share my PowerPoint and see if I can get this going.
Yes.
Can you see my screen here?
Yes.
Okay.
Yes. It's
Great.
presenting. It's presenting only showing.
Can you see now?
No, it's not coming. Yeah.
Good.
Oh.
Awesome. That's, I think, my title slide.
Yeah.
Basically. Okay. Got it. Great.
Screen
Thank
is
you.
there.
Yeah. If everyone can mute, be great. So I can my voice will be more clear for you guys. Thank you. So my topic that I chose this time, and about a month ago, I spoke in another college where we're talking about omni-channel retailing. That's primarily what I'm specialized on, what I'm working on currently. This one is a related topic where we want to do a monolith to microservices. Want to talk a little more detail into that. Okay. Basically, what I want to do is, if you can mute yourself, that'd be helpful. Thank you. I want to quickly go through what monolith architecture means, what microservice architecture means, and give you some examples of it, and then talk through the benefits of microservice architecture. How do we get to microservice architecture implemented in a big enterprise like Nike? And what are the microservice stacks that typically we use, which will be helpful for you guys as students, right? Or even for professors and lecturers in the college, really prepare our students for the future, right? And then take a use case, maybe the one that I'm currently working on with my teams here, which is a typical model across a lot of the retailers, and then talk through that. I'll share a few reference materials about where I kind of learned and where I gathered information in the past, which will be helpful for you. Okay. So what is monolith, right? Monolith, I think the word itself means big, like huge. So monolith architecture in the same meaning, it's a single logical, tightly coupled components that make up a big software application. A classic example of monolith is ERP. I'm sure you all have heard about ERPs, right? Enterprise Resource Planning software. Companies like SAPs and Oracles and PeopleSoft and IBMs, they all used to make, or you still make that ERP platforms today, which was very popular back in the late 90s through 2010. Probably like early 2011, 12, I think. Until then, it was a big popular approach for a lot of the enterprises to go deploy ERP solutions. The reason they did that was it was described as a single tiered software application that can combine various business functions through software components and make this big platform. So you don't need to go build one by one or deploy one by one. They thought, okay, I bring a big box, I put the box, plug it in, open the box, everything works. That was the basic expectations of these all enterprises. So in late 90s, all this started. And when I moved to US and back in mid 90s, or 94, I believe, the ERP deployment started picking up. And by late 90s, it was pretty like hotcakes in US. If you know SAP ERP, or if you know Oracle ERP, you're the top wanted person in the US. And same thing in Europe and other countries as well at the time, because of the demand for people that experience, who has an understanding of end-to-end of everything that happens in an enterprise. Big businesses like Nike, or I used to work for Starbucks, I used to work for another fashion retailer. My background is primarily retail. And all those companies have a standard set of practices. Okay, as a retailer, I need to plan on what I'm going to, first of all, I know what I'm selling, right? I'm selling, say, a coffee, for example. In order to sell my coffee, I need to think about how much coffee I need to procure, right? What does my green coffee look like? My green coffee, I need to roast it, I need to package it, I need to send it to my stores and start making coffee there and sell it to customers. That's at a high level flow. For executing those business process, I need to plan. Okay, I need to procure green coffee. How much green coffee I need to procure? I cannot procure a green coffee from just one single source, right? I have to go across the globe from Africa to Asia to South America. I go procure my green coffee because I want to make sure I have a continuous supply of green coffee for my coffee process that I do at roasting or at the stores for making. So I need to do a 5-year plan based on my current sales. What are my projections for future growth? I would say next 5 years, how many pounds or how many kilos of green coffee I need. You plan it. So the planning component was there. The planning, can you give me 1 second, please?
Yes.
1 second.
Okay.
Sorry about that. I was getting some noise here. So after the planning tells me, okay, based on what you see, I'm going to project that you need 5,000 pounds of coffee. I take that sent to my procurement system. Procurement says, okay, I'm going to procure 5,000 pounds of coffee for you. And procurement takes that information. Before procurement goes, there is a supply planning application that tells me, based on your projection, you are going to roast these many coffees as these different roasting plants. And from the roasting plant, you need to package it. To package it, you need this many bags of coffee wrappers or bags or sacks or whatever you need. And then it goes to stores, and in store you need to make coffee. You need to buy cups where you fill up your lattes or espressos, whatever. So you need to plan each and everything that you need to do as part of the process. So the ERP used to do everything from the planning to procurement to ordering to managing inventories to shipping the products to your stores. Everything is done in one single platform. We were all thinking that's the best way to do it, because these ERPs used to do industry best practices, and they were building a software based on the best practices. So every company thought, oh, great, fantastic. That's how it was conceived. But once we get the software into our organization, then we see, oh, this is not how Starbucks does procurement, or this is not how Starbucks does inventory management, or this is not how Starbucks does order management. It's slightly different from the industry's best practice, so-called best practice. Then we start changing, customizing that. So once you start customizing the ERP, that's when the complexity starts. Because if it's putting a vanilla out-of-box solution, just it's like buying an iPhone. I get an iPhone, I turn it on, I start making, downloading applications. I use the apps, I make calls, everything's perfect. But once you download the app and you have the ability to go start customizing the app, that's when your trouble starts. Because next time when the software developer who made that application has an update, When you download the update, all the customization you did is gone. Now you need to find a way to keep the customization, put that on top of the new software coming in. The complexity starts going up, right? Then it becomes much, much difficult. So the monolith, it's easy. If it's out of box, whatever vendor sold you, you just plug it in, running it, fine. If you don't do that, when you start customizing according to your business needs, that's when the trouble starts. So if we take an example here in the slide that I'm showed here, in a ERP, in an e-commerce application, let's take a web application where I'm selling products online, you'll have multiple functions like authorizing my customers to create their profile one, or take an order from the website, check product inventory, authorize payments, because once I'm buying from a cart, I need to go authorize payments, get it, and then ship the products, right? Or once the shipment is done, now I'm running out of inventory, so I need to go order more products for people to buy it or even ship it to the customers. So if I bundle all of them into one single application, like a product display function or an ordering function or a payment function, everything is bundled into one single app, that is pretty much the monolith. Tomorrow, if I'm going to make a change to my payment process, but if you think about it, yeah, when I go to a site like Amazon.com or Flipkart.com, if you go, you set selection of products. And the product function is the basic common function you see it in a website, because every time you go, you have to see the product. Then you click the product, you put it in the cart, then you check out, you go in. And then you go make a payment. If you look at the entire process, during the product search to the payment, how many times do you think you'll be calling the payment service? Maybe once, because after my shopping, I'm going to put that in a cart, and the final step is the payment. So in that case, what do I even need to combine my payment into the big blob of software that I'm developing? I could separate that out and keep it as simple, right? By combining all of this together, tomorrow if I have to make a change, so I'm right now using a payment of, say, Visa card acceptance, and tomorrow I might have maybe a debit card payment I want to add, or maybe a cash payment I want to add, or other type of payments I want to include it, then I need to go touch this software that handles or function that handles my payment in that monolith application. When I do that, it's not testing just that. You have to test everything from the beginning to the end, your product catalog to order processing, to your card processing, to your payment. So it becomes very complex and time consuming to make changes to these softwares. That's the challenges with monolith. I'm hoping that you guys are getting what monolith means. Nothing but a big boulder, right? It's not easy to move a boulder, or even take an armor at home, right? If it's an armory that you're buying, if it's a 4-layer armor or 4 drawers of armors you have, with one single piece, it's hard for one person to move it. You need help. But same thing, if the armor is broken into 5 different pieces, if it's 5 drawers in it, I can move each one of the drawers by myself. That's the basic concept that we are talking about between monolith and microservice. I think most of the challenges I talked about here, right? It looks very simple because everything is one single box. So I come and plug it in, great, everything works. It's like iPhone, right? Then I can start downloading apps by apps, whatever I need. If you look at an iPhone, even though it's a single hardware with OS and everything in that, it gives you a lot of services that you can put on top of it if you need, or if you don't need it, you can eliminate it. That's kind of the model they're building with the services layer. But big monolith architecture doesn't work that way, because you have a UI layer, you have big logic of business, and then you have your database layers. And those are the 3-tier layers that you see in this ERP applications in general. It takes a long time. I've done 2 different ERP deployments in a whole career in 2 different retailers. I'm working on the 3rd one today at Nike. Each one of them takes multi-year effort. It takes at least 5 years to roll out an ERP. You can think about how much money you need to spend to do that, right? And the number of people involved is also huge. It gets so complicated. It's not easy to maintain because it's too large, and you can't scale it. For example, the previous slide I was talking about web app where I'm going to sell products. People come and use the site to buy products, search it, find out the product they need, put it in a cart, and then make a payment. In that, the most scalable part of it, where most hit service that is the product search, right? That is the one because everybody comes and they start looking for the product. You need to search and find the product the customer is looking for. That service is probably the most used service. And if there are 1,000 customers are hitting my page at the same time, I need to make sure my service can serve the data for those 1,000 customers at the same time. Versus payment, out of the 1,000, maybe 1 or 2 might be doing the actual completion of sale and the order. So they might be hitting it. So the number of hits happening to the payment might be low in this case. But as your customer base starts going up from 1,000 to 100,000 to 1 million to 2 million, then you start seeing it's not only your service, the search engine that needs to scale, but your payment service also start scaling up, because when you have 1,000 customer base, you might probably have 10% of the volume that might be doing payment at the time when others are searching. But when it goes to millions, 2 millions and more, then you can see you're going to have more number of people using the payment service because there are more people buying. So you'll start scaling each and every service depending on the demand. You cannot do that with the monolith. It's very difficult. And then it's not very agile. In today's world, if you look at COVID-19, right? Nobody thought it's going to shut everybody out and make everybody stay home and then work from home, do everything from home. Now I can go to online, I can place an order for a shoe, or I can place an order for a food delivery, or even buy my bathroom needs or whatever it is. It's been done and delivered to your home immediately, or maybe a day or 2 days. Why is that possible? Because of the service layers that a lot of these retailers have built, the portals they have built, the sites they have built, the scalability they have built. They're able to take those volume of orders, because nobody's going to a physical store ordering. Everybody's going to the online to order it. So you can see number of orders coming to the online, number of processes that needs to happen. Unless your systems are designed to scale to support all this demand, there's no way we can make this the COVID-19 sale, the digital sales that we are talking about, to the scale we are doing today. At Nike, I can give an example. Maybe I'll hold up on, I'll talk about that when I talk about the use cases. But the agility, what I was referring here is like, I have a physical store, I'm selling shoes. All of a sudden, I'm shut down my physical store. Now, everything I need to move to my .coms, my mobile app sales and whatnot. Unless I have the ability to scale up and down and make the changes to those sites and apps quickly enough, the agility that I'm talking about, it's impossible for a company like Nike to switch all their sales from a physical store to a e-commerce sales. That's the agility we're talking about. And then a lot of the components you build in the monolith are not reusable. I'll give an example later in the use case as well, but if we take payments, right? I could have 2 different payments for one, the customer who's buying products, the payment. That could be a supplier who might need a payment that I need to process. Payments could be very similar activity. It's all about transaction, but can I use the same component for 2 different purposes? The volume should be higher, the numbers could be different, but the payment is a payment. Can I do that? I cannot do that easily in an ERP application. So the reuse is a big constraint. And we want to build reusable components as part of the microservice architecture. And it's a big single development stack. If you go to a SAP platform, it's all about ABAP language. That's the only language available to develop it. Now, a lot of the new layers they're talking about, which is built on cloud, they might be supporting Java, but again, Java is the only thing they support. They don't support anything else. Look at Oracle, they all PL/SQL codes, and that's what they do. So every ERP has one development language, one set of databases, one set of UI, they build it, and you are stuck with it. You don't have the flexibility to use different languages. Because in a company of 10,000 employees, the IT department itself could be 500, 600, right? And we take Nike, for example, we are about 75,000 employees globally. And our IT employee size is about 7,000 employees. But out of the 7,000, not all the 7,000 doing the same language or same set of skills, right? Because it's so diverse, so different applications are needed. Everyone has a different set of skills. And I should be able to use these skills and apply that accordingly, and then able to scale my applications and the business functions. Unless I have the ability to use those different skills that I have, I will not be successful. So in that point, if you have a single development stack, it is not going to be easy, right? Everybody will talk the same language. It's like coming to India, go to one state, everybody speaks the same language, and then you go to another state, they start speaking the same language. Then it's pretty hard for somebody to go back and forth unless we have a sign language that basically allows me to communicate between different language speaking people. That's the concept that we're going to talk about in microservices. So single stack is not beneficial. I'm going to pause here for a second, for a minute, and maybe ask you guys, anybody has any question I we have understood. I'm pretty sure you guys understand what monolith means and what I've been talking for almost 15 minutes now. Are you guys able to follow me? Do you have any questions on what I talked about monolith? All right, sounds like we'll move forward. So now we'll talk about what is microservice. I think I talked about big boulder, which is monolith. Now I'm talking about smaller stones, right, pebbles here. Microservice architecture is more loosely coupled. When I say loosely coupled, each component can function on its own. I don't know what the other hand, I have two hands, but basically I'm going to talk between those two hands in a common language, common sign language. And I really don't know what the right hand does versus left hand does, but I know it does something. It does something for me, what I'm asking for. But I'm going to communicate in a common language. That's what we talk about loosely coupled model. And in the loosely coupled model, where each component, like I said, can run independently as a separate service. A payment service, it can run on its own. Anybody can come and use it. Whether it's a supplier system that wants to use payment service or a customer who's paying for my order wants to use payment service, I can still reuse the same payment service across two different business functions. That's what we may call it as independent services. We build, business capabilities. Each microservice can perform a function, but a collection of microservices can make up a big business capability. And the example that I talked initially about monolith, if you take in a microservice architecture layer, you saw that, right? Catalog is a separate service, which is the product services and product search. Part services separate, order services separate, payment services separate. So each one of them separate, and I can take it and make use of this in any other websites if I need to. For example, today I'm selling only shoes on my site. Tomorrow I might start selling fashion. I might build another site. I can reuse all these components, except for the catalog service that might need different data, but the service still will be the same. So reusability is a big thing here. So if you change the monolith with a big box to a smaller components, it makes it much easier for me to reuse, and I can scale up according to the demands I have each one of them. And if you also look at it, the databases for each one of the service will be on its own. So that way I'm not having one big database, and if that database goes down, everything is down. Here, it's not the case. Benefits of database, I briefly already talked in the past two slides. I think agility, I can quickly change things. I can deploy each one of the changes separately. If I have a change in order service, it can go on its own. If I have a change on my catalog service, I can build it and run it at its own pace. They're not tightly connected, they're loosely coupled, so they can go at their own pace. They can go their own development, they can do their independent testing without impacting each other. And reusability, and we talked about it, like payment service, for example. Scalability is the biggest thing, in an e-commerce application, like I gave an example, product search is a big thing. Order service will be another big thing. Payments might be the least used, but again, if overall look at it, payments also is a critical component. But if you look at which is the most used, search will be the most used. So the scalability according to the demand can be easily done in microservice. and I can quickly enable the business with the functions they're asking for, because I'm building smaller functions, and I can do more. When I use the agile approach, I can do an incremental delivery, incremental development of softwares to those businesses. Business doesn't need to wait for everything to come at once. I can, add one function at a time and then complete that over a period. And the other big advantage, I talked about the skills, right? I could be a Java developer, I can build my own services. I could be a Python developer, I can build another service. But both services can talk to each other because I have a common language, what we call API contract. I define how you call me, and I tell you how I'm going to respond back. As long as I know how to call you and I understand what you are going to respond back to you with, what we call API, the data payloads you're giving to me, as long as I understand, I don't really care whether you use Java to develop the service or a Python language you used to develop the service. So that's kind of the core understanding here, is that what is my API contract between services? As long as I understand API contract, then I really don't care on what platform it's been built. That's big benefits of these. I'm going to pause again. Any questions? Now, how did we get from a monolith to a microservice architecture, a microservice-based solutions, right? It's a big task. First of all, you need to understand that the cost of doing that is very high, because over the years, a lot of companies have been using this ERP solution for 20 plus years. To really break that monolith and decompose it into smaller services will take several iterations. So for that to be successfully done, the entire enterprise needs to understand what we are going after, what the investment costs are, what is the timelines needed, and also identify the key solutions that we need first. What are the key major bottlenecks that I can unlock for the business? Identify them and start going after migrating them to the microservice layer. So to do that, you need to have a clear strategy and architecture. You have to be very, very clear on how you are going to migrate to microservice architecture. Make sure everybody understands that in the business, especially without a big support from a business leaders. It's impossible to succeed into this migration to microservice architecture. And you have to be very clear on your roadmap. And then you have to prioritize and then decouple all the layers that you wanted to build, right? Start, say, edge services. When you say edge services, we're talking about the websites and the services that are used by websites more often. Like, for example, checkout service, .com sites, the most commonly used services. You want to focus on them first because you want to provide the best experience to your customers, rather than my backend order delivery process, which might not even customers see it day to day. When I'm going to a site, I'm interacting with the site to see product, to buy product, rather than trying to understand how the product is delivered to me. I least care about that, as long as it comes on time, right? So if you look at from a approach perspective, what is the most impactful thing that I can do my consumer or customer who's buying my product, who is interacting with my website, will be the first layer I want to improve it, because give the best experience for your customers. And so typically you start with the edge layers, edge services. And you have to minimize your dependency back with your monolith, meaning like, in order for me to do this, I want this monolith application, backend application, do something for me. I would probably separate that out by building a service on top of the monolith. And so I'm interacting only with the service. I really don't care what's happening in the backend, right? That way, I'm decoupling my edge layer and my monolith separately, and I'm not even worrying about what's the monolith doing. And then decentralize it. Basically, the development of the work, you can't just keep it in one place. You have to have multiple teams working on it. The function needs to be decentralized. You can't have everything in one place. Again, the monolith model itself, right? Move away from that. And the architecture approach, this is something I want to talk a little more about it. Domain-driven design. I want to give an example. I think domain-driven design is a very popular approach a lot of companies do today. And Amazon is a great example here, right? Amazon, when they started building their company 20 plus years ago, I still remember, I live in Seattle. Amazon headquarters is about a mile from my house here, exactly a mile from my house. The company, when they started about 24 years ago, I used to park my car behind their building. It's a small warehouse where they had racks of goods, and they used to put in a truck and move it out. And I had no idea what they were doing. I thought it was a library. But later I realized, and all they had is like Amazon.com on the back of the wall. It's a street parking. I used to park behind this. I'm talking about 96. Okay? And a few months later, they moved to another building. 2 years later, they went public. And today, if you look at the company, nobody knew Amazon.com. I wish I had bought their stocks 22 years ago. Today, the value of the company is 1.6 trillion. How they got there is because they built the foundation so strong. Every product they build, they thought through it so well from a domain model. They created so many domains. A domain is nothing but a business function. You take it and call that a domain, meaning payment. Let's take a payment. That is a domain by itself. So once I carve out that payment, everything that I want to happen within the payment is called payment domain. I build the services around it. I build it such a way, Amazon, this is what they did is, they built a service that they really needed, but not only that, they build it such a way that they can sell the payment as a service for another company wants to use it. That's how the whole AWS cloud concept was started. Amazon wanted to have an automated scaled infrastructure platforms, and they started building them service by service. In a domain-driven design, if you look at it, a database is a service itself. That's a domain on its own. A server, a CPU increase in a component is a domain by itself. So I can just increase the number of CPUs I need. Memory is a separate service. That's another domain that I build it. How much memory I need, my real-time RAMs, and I can do that separately. And data storage, the database, the actual hardware, the side of storages, that could be a separate service I can increase up and down. So if you look at it, when it comes to a server, if I break the database server into the actual database, the data storage, so the physical storage, a CPU, a memory, and even the power consumption for that matter. Each one of them are separate domains, and each one of them are separate services within each one of their domains. That way, I can completely disconnect it. I really don't understand what each one of the other domains does. All I know is to connect each one of the domains. I need to understand what I need. I need to understand what they're going to give it to me. When I ask a question, what is your name? I'm going to say, my name is Gopi. Yes, but what does that language mean? Gopi means, I'm going to speak language English, so it understands the language of English. And that is the understanding between you and me, that whenever I ask your name, you're going to give me the name, and the language we're going to speak between us is English. That's all I need to do, right? Once I know that, I put that in an API contract. I don't need to care about whether it's a man or a woman or child or whatever behind the scene. I really don't care, as long as you're answering my questions. And that completely decoupled model is called the domain-driven design. I think it's a big topic, maybe an opportunity in the future, maybe to talk about domain-driven design. A lot of companies started following that. Amazon started following, and they've been very, very successful. And I would probably, I've not put any references, but I think for you guys, please search for domain-driven design. There are so many books available. Start reading them. I think they're excellent concepts, and more and more companies started moving towards. As you guys come out of college and start working through this service layers and all that, having a good understanding of domain-driven design is a great thing to have. I'm going to pause again here and ask a question. Probably is a good place to stop before I jump into the technology stacks and other things.
Yeah, no questions till, so we can proceed, and people will ask queries.
Okay, we'll go forward. So, I mean, this is probably the most interesting part for you guys, right? As the students, I think, what do I need to learn? What do I need to do in order for me to become a microservice developer? One thing you remember, I want to be, very clear on what we expect as, as I go through my hiring process, look for architects or engineers. We don't just look for a person who can just code, right? Technology is easy for anybody to learn. Just coding is not going to help. But having the business knowledge with you is the one that's going to make you more successful. And pick a domain as a retail domain, or within a retail domain, it might be a planning specialist, or it could be an order management specialist, or it could be a logistics specialist. But start picking an area and start going and understanding the business functions of it is very, very important. Just having a technology itself, it's not going to help it. Maybe to start your career, yes, you start with some technical skills and languages, and then start learning into the business process. As you go into a career, let's say third year, fourth year, fifth year, or eighth year, your business knowledge along with your technology skills is going to really make you powerful. Okay. Application stack here, right? I already talked about Java. Node.js is another Java scripting that's been heavily used today. But we have a lot of frameworks that are available, Spring Boots and other things that are available. Start learning them. The middle tiers where we do a lot of monitoring, there are so many different components and tools, open source tools available. As we build services, one key thing that we always look after is monitoring my own services. Like if I put a service in production, it starts running, I want to know what's the health of that service, meaning who are all calling, how many times are they calling, what responses are going out, is that it's meeting my SLAs, meaning I said that I respond to this call in less than a second. Am I meeting that promise of what we call SLA, service level agreements? If I don't monitor and look for those SLA data, I may not be doing justice to my own service. So you need to monitor your own work, monitor your own services. And finally, make sure service is up and running, right? If it goes down, you want automatically alert someone to say that the service went down so you can immediately react. Or you have to have a failover approach where I say, if service goes down, create another service. And I think in the Amazon world, what happens today is, I was giving an example, if during a big promotion sale happens, Diwali sales, for example, when it happens, if I have a major promotion, discounts going on, a lot of people will come and buy. So during that time, my demand on some of these services will be really high. Product search, order services, payment services, the demand for those services will be high. So I automatically scale them up to the demand at that time. I may probably have a promotion sales for 6 hours, for example, right? During the 6 hours, the demand will be really high for all my services. So in the cloud space, what we call auto scaling, depending on my traffic increase, it automatically spins up more and more instances of these payment services, order services, and search services. So people, as they come in, it'll start, load balancing them and have them go across these service layers, and it will meet the performance needs. Once the promotion is done and it starts seeing that the sales is going and the number of people coming to the site goes down, I can automatically shut down all these instances I created in the cloud and go back to my normal window of saying, by default, I always run 3 instances of my payment services, 5 instances of my order service, and then maybe 10 instances of my search service. That's my standard. But during peak, I can go from 10 to 100 or 2 to 20, whatever the auto scaling number I set up. I can go to that many instances and then scale back in. So the auto scaling is a very key feature that every company uses in the cloud. And for that to happen, the monitoring is key, right? Understanding what does my traffic look like, who's calling my service, how many people are hitting my services, what data is going out, what's my SLA look like. If I'm not meeting my performances up, if I'm queuing up more and more calls coming to my service because I'm not able to respond to that quickly, or I don't have enough instances available for those queued calls to go in, then I need to automatically be alert and do something in the background. So being proactive monitoring is good. It's like health check, our own health check, right? If my BP is good, my sugar level is good, am I breathing fine? all that we do in a day-to-day, we do the same thing with systems. So that's very important, the monitoring. I stress on the monitoring because that's very, very important. And then DevOps, I think, DevOps world is nothing but you build your code, you support it. It used to be like that, when I started my career. I built my code, and then I used to be a developer on IBM platform back in the early 90s. And then moved over to SAP to, Oracles to Java to I worked on pretty much every platform. In those days, when I started my career, I built my code, I supported. And over the period, because this technology got more complex, people started building different teams. One to build the solution, other team to support it. And those days are gone. Now we are back in the early 90s days. I was like, okay, we call it DevOps now. You build the code, you start supporting it. Then you know the pain of what you made mistakes, right? So for that to be successful, for a DevOps to be successful, you need to have these tools available for you to be successful with the DevOps. So there are many things available, Kubernetes, containers that heavily used, right? I can build a service, put it in a container, and probably using a lot of terminologies. If you're not familiar with it, it's all cloud related. I can put it in a container and I can move that wherever I need. I can take it from one cloud platform, AWS, to Azure or to Google Cloud without any impacts. So cloud is nothing by putting something in a box, which runs on its own with every hardware and software, OS and CPUs and memories, all that you need. Configured in the container, I can move from one instance to the other without problems. So the cloud has given the flexibility for the DevOps teams to be successful. Okay. And all others, I think, like containers is what I was talking about, orchestration service through the Kubernetes and others. So for a new college student, if somebody asks me, what should I be focusing on? I would say, if you love Java, start Java. Python is widely used for service development today, especially on the AML side, right? I did not talk about that yet. AML, artificial intelligence and the machine learning has been heavily used in a lot of areas today. We are experimenting many solutions today in my space itself. Like I talked about green coffee planning, right? How do I gather all the data I need, run through those algorithms that was built by a lot of super brain engineers, and really crunch through the numbers and quickly tell what my future would look like based on my demand. And we used to do that, we built some logic. Of course, there are algorithms, but these algorithms are more advanced. They can try to think more like humans, right, with the artificial intelligence. Those are the new technologies that are coming out. Start learning, reading, understanding of what that means. Machine learning is another big area that's exploding right now. So learning Python is another key area because a lot of the machine learning tools and solutions, Python is a key language. And then after that programming languages, then you want to understand those monitoring things, what's happening, and then understand how to use a container, how to use a Kubernetes from a cloud development perspective. Those are important things for you to learn. And also try to get, and I think I put like the paths here, like for you guys from a development perspective. I pulled it from the Amazon site here. This is something I've recommended in the past to a lot of my junior engineers, right? Start learning, pick up any cloud platform and start going through the certification process. Start with the basic developer certificate, what they call associate certificate, and you can move on to more doing an advanced developer certification within AWS. I think this path is a great path for you to go start your career with. I think everyone takes a different path when you come out of college, right? But if you want to go into more deep technical space or become a cloud engineer, developer, this is the path I would recommend for you guys to take a look at. Okay? Now, I talked about the technology we use in microservice architecture space. I want to quickly talk about the omnichannel retailing. Omnichannel basically means everything in one, right? This is not a monolith, by the way. When I say omnichannel, you said a monolith it's not the way to go. You said you break down everything. Now you're talking about everything in one place, which is called omni. This is from more business model perspective. Omnichannel basically means what I do at my physical store, I should be able to do that at my site, or vice versa. An example is if I can buy a product online from a website, and if I go to the physical store, I should be able to return that product without any problem. Same thing, if I bought a product from a store, unfortunately, I'm not close to the store, I want to send it back, then I can go to online and say, I want to return this product. They give you a shipping label, take it to a local shipping location and drop that box, and you're done with it. That is what we call about omnichannel. Everything is completely integrated between the physical store to an online store. Everything is integrated. And remember, I talked about reusability, right? The payment services I build for my website, I should be use that on my point of sale in my physical store as well. That is a reusable, it's a classic example of reusability. So in an omni-channel, I can buy a product online, I can go to a store and pick it up, or I can get it delivered, right? Or I can pick up, order at the store and have it delivered from to my home through an online shop, whatever they have. Same thing, I talked about an example of returning back on an online. For an online store to be successful, we need to have a centralized inventory management system. Or sorry, when I say online, I just said online for omni-channel retailing. So why I call out inventory to be the key component is that I need to know what is that in my store, the inventory perspective. How many shoes of model A and model B and model C has in my store. Also, the website should be able to see the same inventory information so that it can sell that through the website. Or if somebody comes and picks it up from my store and they're trying out in a separate room, I should not be able to sell that inventory, that the product that's currently being tried out by another customer in the store. At that time, I need to let the store know that, for example, say I had 10 units of product as shoe type A. And if one of them is picked up a customer to try it out in a different area, a different room, then now the 10 units should become 9 for an online store to see it. And I'm not going to sell the 10th unit because somebody else is trying out. That's the level of capability we are looking for to build. And in order for that to happen, you need to have a single view of inventory. I'm talking a little bit of business terminologies, business process here. I don't know how much of these knowledge you guys have. A lot of students, I don't know who are the type of the students there, right? Or you guys are MCA students or be computer science, that could be a variety of students, but and having that business knowledge is very helpful. And inventory, I'm pretty sure it's a common terminology, everybody's familiar with that, but a lot of the omni-channel retailers today struggle because they don't know where their inventory is, what inventory they have it, how do they provide visibility of their physical inventory sitting in a store to their online store so that they can sell it. Once you find out how to do it, once you solve the problem, a lot of the omni-channel retailers are very successful. I can give an example of Nike. By the way, I tried to remove any references of Nike here because I'm not supposed to speak on behalf of Nike. I'm just speaking on my own personal time here, but I can definitely give an example. Nike, before this COVID-19 situation, we had digital sales of about 15% of our overall sales were through the digital channels, like .coms and mobile apps. Now, most of our physical stores have been closed. Some of them are partly open, they're not fully open yet. We had to move all our sales to the .com sites and the mobile apps or through digital channels. Our sales have gone up from 15% overall to 30% of our sales are happening through the channels, digital channels today. Our goal is to bump it up to 50% in the next couple of years because there's more and more people are going to online buying it because they know what shoe they normally buy, because a customer, when they buy a type model of shoe and they are used to it, they always buy the same model of shoe because it will come more refined models, but they continue to buy that. So I don't need to worry about size not fitting me or having uncomfortable situations with those products. If you have, you always can return it, but a lot of times the repeat customers try buy the same products. So all of them finding it so easy to go online and buy it, and they have an easy process to return it. So our sales have gone up so much, and we don't have capacity in our warehouses to ship those products. Because of that, we have backlog of orders that are sitting in our warehouse and to pick and ship. And with the social distancing in place, it's pretty hard to have more people in a building to go pick and pack and ship it. That is the situation we are in. And we are able to do that because of the uh, centralized inventory visibility that we have. I know what is there in my store. I know what is there in my warehouse. With the combination of those two inventories, I can easily sell those products online. And I can promise that I can deliver a product to someone, and I can do it because I have visibility with the inventory. Companies like Nike, right, their customer service is number one factor. They focus on customers so much. I know it's different in India. Some companies do that very well in India, but in most of the companies, the return policy is very different. But in US, by law, every state provides customer focused laws that if you buy something and you have the timelines and you have the ability to go return the product to a store if you're not happy with it. So customer satisfaction is very, very important. And laws support that. It's not that India doesn't have it. India does have it, but I don't think it's been enforced very well in India. But I want to talk through an example here. This is something that we recently been working on. I talked about domain-driven design, right? If you take this again, a lot of business process, business capabilities I'm talking about. Just hang in there for a minute if you're not following this, and I'll try to answer during the Q&A. When it comes to order processing, I capture the order through my mobile app or .com site or through some store or whatnot. Once the order is captured, I make sure that it's not a fraudulent order. I make sure I have inventory to fulfill the order. I make sure I gather the payment for the customer, so I run through the payment process. Once everything is done, now I need to go find where do I have an inventory. I know there is an inventory in my company somewhere, and I need to find what's the best location because let's say an example, I have 20 different locations where I have the same product. But as a customer, if you take US is big country, right? Almost the land size is 3 times than India. The population is probably 1/3. Now it's like 1/4 of India. So you can imagine how wide and how broad it is. So the East Coast and West Coast, there's a 3-hour time difference because of the location we are in. But it's almost like a 5-hour flight for me to move on the flight from the East Coast to West Coast. So that long it is. So if I have 20 different locations across this country, if I'm a customer living in West Coast, for example, I don't want to ship a product from East Coast to West Coast because it's going to cost me a lot. I want to find a location somewhere in the West Coast, close to my home address, close to my PIN code or zip code, and find the product there and then ship it because it's going to be cheaper and it'll be faster. So that is what we do in the fulfillment services layer. First, I talked about order, which is its own domain. We call it order domain. And everything related to that, the order service sits there, like order validation, order capture will be a set of services. Fraudulent will be another set of services I can provide. Payment will be another set of services because payment belongs to payment domain. Fraudulence become part of the security and fraudulent domain. Order domain just does only validation, captures, and any changes I need to make to the order that sits in the order domain. Fulfillment is the next piece where I'm going to go find where is the best location I can find the inventory so I can ship the product to the customer. So fulfillment service is own domain. Once I find it, now I'm going to send it to the warehouse where this actual product is there, like the DC where it is, right? Send the order to the DC, distribution center. Once it comes to a distribution center, that'll be, people will be watching with the mobile apps because they got an order now, they need to go pick it up. But there is an orchestration service within the platform, what we call warehouse management platform. There is an operation called fulfillment. Fulfillment, in order for the fulfillment to happen, Fulfillment is a high level, nothing but go find the product in my warehouse in the location where it sits. That is called picking process. Once I pick it, I'll see how many products I need to pick for this order, maybe one or maybe two or maybe 20. Bring all of them together, consolidate them, put in a right package, which is called packing, and then print the labels, where the shipping labels on top of the box, and then ship it. For me to print the label, I need to do one more step, which is another set of services here. What I talked so far about picking and consolidation, packing, and printing is a different set of services, and we call it as the node operation services. And again, sorry for using a lot of these business terminologies. This is happening within like four walls of a building where I have a warehouse. There are a set of people working in a warehouse and asking each one of the person who has a mobile app, who has a job of picking and packing, go pick the product from location A, product 2 from location 10, or product 3 from location 15. They bring everything, consolidate that, put it in a box, what we call packing, and then print the label. The print label, it can't just print label because who is actually going to carry this box to the customer location? A carrier will be doing that. And where is the carrier sits? The carrier sits with the logistics. Logistics mostly the shipping part of the trucking part of it, right? And that set of services are what you are seeing in the last layer here. And we have a service called carrier selection. So based on where you live, my maybe living 5 miles from my DC or maybe a mile from my DC, then I can decide, depending on how far you are from my location, I can choose different carriers to ship it. An example is if the customer is maybe like 2 miles from my DC, I don't need to have UPS or FedEx or big carriers to go deliver the product. I can pick up Uber or Ola. Right? Ola is being popular in India. I can have an Ola service come and pick up the package and deliver to the consumer. It's much cheaper to do that way. So those decisions are done under the logistics platform, what we call logistics domain. So that has a collection of services. Go find the product, find the carrier, find what's the best how to ship the product, what's the best price I can get to deliver the product, deliver the shipments. Everything is calculated and done by this carrier selection process. So when I'm printing label has 5 different steps within it, and it'll give me the printing label information I printed. It sounds so simple in this layer, all I'm saying fulfill, but under fulfill, each one of them are separate services that I can connect with any other process I need, but they are independent services, and I orchestrate the process. Fulfillment is a big orchestration service that tells, okay, go pick this product, consolidate all the products you picked up, package it, print it. Print now say, oh, I have another orchestration need to do. What is that? I need to go find the carrier and to find which trucking company is doing it, what is the route it's going to go, schedule an appointment for them to come and pick it up, now ship it. So this is how we break a fulfillment process that happens in a DC into a much smaller business function, and each one of them are its own microservices. I went pretty quickly at a very high level, but just to give you an example of how we break each one of the business function into smaller services, they're completely decoupled, they run on its own, and I can connect it through the API contracts I have, and I can orchestrate all these services together to make the business function called fulfill. Okay. This is a simple example of what happens in a DC. For the use case purposes, given the timeline, I just wanted to go through this quickly. I hope this helps you guys about understanding of what monolith means, what microservices means, and an example of what I walked you through happens in a DC for an order fulfillment. Okay. I already talked about the reference materials before. Now I'm going to leave it to a Q&A session. Hope this is helpful. So I'll let you guys open and ask questions.
Okay. Any questions you can post in the chat box and you can speak. I request Lavanya to coordinate.
Yeah, good day all.
Sir, there was a question on microservices architecture. Can we use AI for auto scaling?
Yeah, of course, because I think the monitoring, today they do that, right? Depending on my monitoring, that's why I kept saying monitoring, look at the monitoring and automate, as much as intelligence you can gather and use that intelligence to make your decision is the key. Of course, you can use it.
There's another question, sir. Can you suggest the time limit that may be adopted through AI for effective usage by learners?
Effective usage by what?
Effective usage by learners.
A timeline, let's say a learning timeline, is that the question?
Yeah.
Yeah, that depends. I mean, it depends on your background and your knowledge in the space, but typically, I would say, in an average of 6 months, you should be a good state. I think get to a good level of an engineer to use the AI. Because a lot of patterns are available today, a lot of catalogs are available. You can reuse those standard catalogs that are available, or you can build your own catalogs in those areas.
Sir, another question is how to implement this with IoT, sir?
IoT, yeah, sure. IoT, like the example I talked about in the order delivery process, right? Today, Amazon delivers the order same day, right? The same day delivery, when the truck leaves their DC, they will send you a text message saying, it's out for delivery and expected to come to your door, to give you a time window, maybe 2 to 4 p.m., whatever, because the traffic is another area you cannot predict it. And as the truck moves from their warehouse to each one of the streets and start delivering each one of the product, and when it comes close to your home, they will send a notification saying, your package will be arriving to your door in next 10 minutes. They have like 5 more stops to do, and they'll be there in the door in 10 minutes. How are they able to do that is through those IoT devices, because they have GPSs on their trucks, and they track them. And every movement of that truck is being monitored, and they trigger the messages based on how close they are to your location. Of course, you can use IoT. And I want to go add to additional information on the second question, about the timeline on AI learning and all that. There are 2 parts to it. Building an AI engine itself. I think it takes a lot of learning. It's not going to be 6 months, because you have to be really, really sharp and building those algorithms, things like that. If you're going towards that path, it's going to be a long path. But using an existing AI engine to apply to your business or business functions you're performing, like auto scaling that someone was asking a question, that might be quicker because you're using somebody's algorithm, then you are learning how to apply the algorithm to that.
Thank you, sir. There's another question. How to make sure the efficiency of the small services in omnichannel?
Small service efficiency of, I think, that depends on what the function is and what the demand of the function is. Like I gave an example of payments. I repeatedly talked about payments and services. And inventory was the other one I talked about. Depending on how much your service is needed. Inventory in an omni-channel, for example, is one of the high demand services. And you need to have real-time information, and you need to scale the service as much as possible. And your code needs to be much simpler and less complicated, and you break the function into much smaller. As you start breaking them into smaller services, like business tools, what we call, right? Let's take an order. If I want to validate an order, first I want to make sure the product I got in the order is a valid product or not. That's one rule. I say, check the product is a valid product or not. For that business tool, you want to write one service, one business service. The rule number 1 is service number 1. If you simplify it to that level, then you can be more efficient, more effective.
The next question is, kindly differentiate vertical and horizontal scaling service. Horizontal scaling.
So vertical scaling is pretty much like, take a server, right? I can increase my CPU, I can increase my memory, I can increase my storage and what is needed. That's pretty much what you do a vertical. And so using that to really make my services run faster, right? Horizontal basically means I'm going to multiply my number of instances. I gave an example in auto scaling, depending on my traffic in my site, I can increase the number of instances of my search engines, or my search service, or my order service, or my payment service to run. That's going horizontal. That means that each one of the servers will run on its own virtual machine, and that machine will have its own CPU, memory, and storage and everything. But I can shut down as the process ends, or I start descaling it and to bring down to the minimum. So horizontal is going wide, replicating same thing. The vertical is pretty much like how one, but then you are trying to increase the power of that one to the maximum level you can.
Thank you, sir. The next question is, can we use Python for logistic purposes other than AML?
Sure, yeah. I mean, AML is is an engine that you're going to use it. Python is a language that you will use to develop a service. So for development purposes, of course, you can use Python.
So the next question is, transitioning from monolithic to microservices can be incredibly hard. Any best practices you could suggest or recommend a transition?
I think I talked about, there was a slide that talked about, the journey to microservices. And your architecture and strategy is key. You need to prioritize, decouple the components that you wanted to move to microservices. And you need to follow a domain-driven design model.
Okay, sir. Sir, the question is, what are the tools to be helpful for monolithic to microservices?
Yeah, I also talked about that in the slide. Basically, how you're going to build your services, the platforms that you're going to build on it. From a Java to Python languages to, monitorings to, containers where you put your services, using all the cloud platform features, are some of the key stacks and technologies that they can use.
Sir, the next question is, suggest some frameworks for microservices.
It's a broader question. The framework, when I say framework, I think it all depends on the languages you are using, right? It's not just one. I mean, within a Java, you can use, some people use Node.js also for some service layers, but all depending on the languages you're using.
In microservices, any other example you have, like e-commerce?
I think the fulfillment is one area. Inventory services will be another area. So if inventory, there are different types of inventories, right? I can just give visibility to what I have. Somebody wants to know. Or I can say what is available for you to sell it. Like if I have 5 different customers who are trying to sell my own products, each one of the customers have a different set of rules that I apply. Customer A, I know he can sell most of my products. I'm going to give you more inventory. Customer B, normally okay, so I'm not going to give you much. My customer D could be least of my sales customers. I'm going to give him very few, maybe my lowest considered customer. So the availability service is another breakout of the inventory services that I call it microservices, that can tell what each one of the customers can get it. And within that service, I can break it down even further, saying how am I calculating those rules? How I'm calculating the numbers that I need to tell to customer A to customer 1 to 2 to 3 to 4. Those rules can be separate services. And then reservation is another services on the inventory space. Reservation is nothing but when I am buying a product online, I need to make sure I find an inventory. As soon as I find the inventory, I want to put a reservation on. Nobody else can take it because they know that order 100, now it's attached to this inventory 1. That way it is secure for what we call reservation. The other service we have built on the inventory is sourcing. Sourcing is basically finding a location where that inventory sits, right? Those are the major functions like visibility, availability, reservation, sourcing are the 4 major services in an inventory platform. That's another example I can give. It's a big topic. I think if we go in each one of them, I can talk for hours, whether it's order services or inventory services or fulfillment services. It's a large space.
Thank you, sir. The next question is, what are the tools to be helpful for monolithic to microservices?
Tools, I think I talked about that. Again, this is basically all these stacks that are available today.
So what are the security issues you're facing, sir?
What are the securities is a very generic question, but security is about your data security, right? Customer profiles. Somebody might hack in, somebody might create a fraudulent order on your site. Like in a Nike world, Nike sells certain special products, like they make like 600 or maybe 600, 700 units of a special shoe, and they sell it online. And once a month, they have this special launch process that happens. So to buy those minimum 600 units available, there'll be millions of customers will try to bid for it. They will not be able to find it because out of the millions, I can serve only 600 customers. So a lot of people, what they do is they have bots. They build it like the engines, the automated engines. They build it and trying to go fire their orders. And those are fraudulent orders. They're not true customers. They're trying to hack and trying to create those because the products that 600 or 700 units that we sell, aftermarket, what we call like secondary markets, I buy it and sell it again, the what we call aftermarket, the value of those $100 or $200 shoes will be about $1,000, $2,000, depending on the model. So people are after those, and there are people who collect it. So that's a big demand. So they try to create those fraudulent orders and trying to hack into the system and trying to buy those products. So those are some of the security examples. Data encryption, try to authenticate into a site with some fraudulent or fake IDs are very common.
Sir, the next question is a very general question. We would like to hear from you as you are a good IT professional. From students' perspective, how you would advise them to equip themselves to get placed in this pandemic situation? Or is there any special certification will help them in this particular domain, omni-channeling domain?
Yeah, I think like I said, try to focus, maybe get like a cloud developer certificate that really puts you ahead of everyone else, right? Learning about cloud technologies, becoming a cloud developer is really, really important today. Everything's on cloud. And picking up and learning one of the key languages like Java or Python that makes you a microservice developer on a cloud platform is probably the path I would suggest. And trying to build, prototypes on your own, right? Maybe 2 or 3 students can join together, think about some solutions that exist in today's world, right? Be creative. I think COVID-19 is a situation that nobody has gone through, and how to get a job, how do you find it? We're all learning, right? But staying on top of the new technologies, learning AI, ML, or getting a cloud certification is very, very important.
So there's another question, how the product request and payment services are handled in both the framework by synchronous or asynchronous method?
They're all synchronous. Nothing is asynchronous in the omnichannel and the .com sites. The only asynchronous call will be like once I'm done with my services. Once I'm done with my order payments all through, I can file the order to the back end and forget about it. Basically, send it to the back and let that back end handle how it's going to ship physically from my warehouse to the store. At that point, all I need is like once in a few hours, give me a status. So we'll do a async call for that, but everything else is pretty much a synchronous call. The only
Yeah, thank you, sir. Actually, these are the questions from our Google Meet and YouTube link viewers.
All right. Thank you. I hope this is helpful to everyone and appreciate the opportunity that you given to me to speak on this topic.
Yeah. Thank you, Gopi, for your valuable information. Very informative.
Yeah.
And I think our most of the participants have asked active questions also. I think I've answered, and it would be useful for them during this COVID-19 pandemic.
Sure. Thanks, Chithra, for finding the opportunity for me. I appreciate everyone.
Thank you so much for your precious time. I know USA now you are in the night time and you are helping us. Thank you so much.
Oh, you know, no worries.
Yeah, now I request Dr. Mrs. Ornam to give the vote of thanks. Before that, I would like to make an announcement for all the participants. So today we have scheduled for 2 sessions. 4 to 5:30 we have scheduled for Cloud SaaS Evolution by Mr. Anbu Ganapati Muppidadi today. But due to, I think, natural calamity at New Jersey and New York, thunderstorm is there, it seems. Because of that, they are unable to connect. I think this Mr. Anbu Ganapati is unable to connect with us today. I think due to internet and no power problem. So let us have this scheduled in the next week. It will be intimated in the WhatsApp group. I request all the participants to note this and bear with us for this afternoon session cancellation. At the same time, definitely we will reschedule it and we will conduct it, and that will be intimated to soon to all the participants. Please note this, all the participants. Thank you so much for your patience to listen. Now, I will hand over to Dr. Mrs. Swarnam.
And before Dr. Sonam say, I want to convey the apologies on behalf of Anbu Ganapati. I know the situations he's going through in New Jersey, but apologies for not able to make today for his speech.
We are actually ready to wait for 1 week more to hear to the informative session, sir. So don't take apologies.
No problem.
Just postponed and not cancelled.
Okay.
Okay. Thank you, Chithra, for giving me a wonderful opportunity for me to express our sincere gratitude. So it's time to express our gratitude at the end of any event. So I am so proud and privileged to propose the vote of thanks on behalf of our department and the entire organizing team of this international webinar on cloud and enterprise architecture. First, I would like to thank the Almighty who made this event to happen in a grand, successful manner. So in fact, I think all of us will agree that we didn't feel that the 1 hour 30 minutes we have spent on this enlightening webinar. I express my sincere thanks to the resource person, Mr. Gopi Parashurama, who made this event a grand success, and hope he ignited all the young minds of this forum in a very elegant way, with a simple English, of course, and in an understandable manner. Though it is a very crucial time around the world due to COVID pandemic, our prayers made this event a grand success. I would like to thank university authorities, especially our HOD, without whose support this wouldn't have come true. I would like to thank each and every person of this organizing team, all the professors and other professors from different universities, colleges within Tamil Nadu and from other states. I would like to thank the backbone of our department, especially our students, MCA, MSc, MCA lateral students. Last but not the least, I would like to express our sincere gratitude to all our research scholars of our department who have worked day and night to make this event to happen in a very smooth manner. Once again, I thank all our fellow colleagues, particularly special thanks to Professor P.L.Chithra, convener of this program, who have done this international webinar to implement in a grand, successful manner, though he has faced many hurdles to come it through. I request our team members to conduct more such programs to make our students more employable. And I thank all the delegates, one and all, present here in the midst of their busy schedule. Thank you.
Thank you, Swarnam.
Well, yeah. Thank you so much. Thank you, everyone. Thank you, Dr. Swarnam. Appreciate it. Thank you, Chithra, for the opportunity, and wish you all a good health and a good day.
Thank you, sir. Thank you.
Thank you so much. Thank you so much, Gopi Parasurama, for your enlightened, informative session today and joining with us with your sparing your precious time with us. And I would have contacted you more time, and he has extended his help at any time. Thank you so much.
Sure.
And we will keep in touch. And I request this opportunity to give some internship help and other things to our students also. Thank you so much.
Great. Thank you, my precious. See you guys. Have a good day.
Thank you.
Bye-bye.
Good day. Bye.
Thank you, Chithra. Thank you, one and all. Bye. Bye.
Bye. I request all the participants to fill up the feedback link which is posted in the chat box, and you will get the certificate immediately. So I inform you that please bear with us today due to their pandemic. I think also along with their natural calamity, the other resource persons could not be able to join with us today, but it will be scheduled again and intimate to you. And all the participants are requested to join with us again in the next meeting. It will be intimated in the WhatsApp group and your mail too. Thank you so much for everybody for your fullest cooperation. I take this opportunity to thank all our department staff, university authorities, along with my students. Those have helped me a lot, specifically all my research scholars, Kamalmati, Deepa, along with Chandru from our department. Thank you so much, one and all present here. Have a good day. I think feedback link will be there for another 10 minutes. You can fill up and you will get the certificate immediately. Thank you so much.